Okay, still dealing with the same thing, but this just simply states find the limit. Now, the only thing that you're asked for on this example is just the limit from the right-hand side. Again, always try direct substitution first, but if I were to do my direct substitution, I would end up with 3 over 0, which is going to mean limit does not exist, but why does it not exist? Now, you've got a graphing calculator. You can definitely graph this to figure this out, or like I said, you can just start substituting in numbers that would be to the right of 1, and then just see if your y values are getting larger or getting smaller. Alright, I've gone ahead and put this in my graphing calculator. So this is the graph of this function. But again, you're just simply looking at it from the right-hand side, which would be this portion. Of course, here's your positive 1. That's where you've got a vertical asymptote. So your graph is unbounded. It turns and goes down forever. So again, the limit does not exist, but it does not exist because it goes to negative infinity. Okay, next. Okay, same instructions, doing the same thing. Okay, this time I have the limit as x approaches 3. Now this one doesn't specify from the left or from the right, so that means you do have to consider both. Again, try direct substitution first. Actually, if you do direct substitution on this one, then you're going to end up with 1/9. So this is actually not even one of these that's considered the infinite limits. I mean, this would just go back to what you had done in section 1.3. You were able to take the number directly substituted in and get a real value out. So your limit is 1/9. I just threw this one in because you do have some of these mixed in your homework along with the ones that are infinity and negative infinity. So always check direct substitution first. Okay, next. Okay, so this one's going back to a one-sided because we are approaching from the right-hand side this time. Now, think about direct substitution again. If you were directly to substitute pi over 2, of course you've got negative 2 as your numerator, but cosine at pi over 2, or 90 degrees, is actually 0. So that would mean that this does not exist because you're dividing by 0, but why? Now, putting this one in your calculator though, so of course I've got it in my Y3 this time, but what you would need to do, because your x value is not just a typical 1, 2, 3 type value, is in your window, we actually need to adjust this. Since x is approaching pi over 2, you need your tick marks to be using these type of values. So I'm going to start at negative pi over 2. So I just like to make sure that I have my y-axis in there. I like to be able to see it. But since I'm only looking at it out to pi over 2, I'm just going to go a little bit past pi over 2. I'll just go to pi. But I'm going to put my x scale at pi over 2. And I'm just going to leave my y-axis like it is. Okay, so remember I started at negative pi over 2 and I went to positive pi, but by me putting my x scale at pi over 2, that's what this tick mark is. So of course this is 0, this is pi over 2, which is 90, this is pi, which is 180. But that way you know for sure exactly where pi over 2 is. This is pi over 2. And that's why you do have the separation in your graph there, because this is going to be a vertical asymptote. We are only looking at this from the right hand side, and what happens is your graph turns and goes up forever. So that's equal to positive infinity.